Hello everyone, welcome to Electronics Hub. So right now we are starting a new series 8051 microcontroller programming. We'll use Kyle for programming and Proteus for simulation. If you want just programming, then you can skip this video. In this video we'll see block diagram and pin diagram of 8051 microcontroller. So we'll start with block diagram. This is the CPU of our microcontroller. It fetches the instructions from ROM and executes them. Hence the arrow is from ROM to CPU. This is interrupt control. When external interrupt or internal interrupts occur, then the subroutine is executed. Next is RAM. While performing operations, we use variables and those variables are stored in RAM. Then timer. For time critical operations, timer is used, and we can use timer as counter as well for computing the time interval between two events. Next is serial port. Okay, this is for reception and transmission. Serial port. For serial port we can use serial interrupt as well. Next is IO port. IO ports are bidirectional because of its name only, input and output. We can interface output devices like LCD or keyboard, and we can also keyboard is input device, and we can also interface sensors as input device. Next is bus control. We can use a data bus of 8 bits or address bus of 16 bits. And the last but not the least, oscillator. Oscillator provides us frequency at which the operation of our CPU is carried out. So instructions are fetched from ROM to CPU, hence the direction of arrow is this. And for others, CPU executes, and according to the execution, bus control, IO, serial, timers and RAM, they are changed. Hence the arrow is from CPU to RAM to timer to serial port, IO ports, bus control. And sometimes CPU reads the value stored in RAM or timer, hence this is bidirectional. So we'll now move pin diagram. We'll start from pin 1 and end to pin 40. P1.0 to 1.7 are port 1 pins, IO pins. Okay, this is reset. When reset is clicked, the microcontroller is resetted. That is, execution starts from first instruction again. Then P3.0 to 3.7 are port 3 IO pins. They have extra functionalities like 3.0 and 3.1 are used for serial communication, reception and transmission. 3.2 and 3.3 are for external interrupt. The bar shows that they are lower edge triggered. Then 3.4 and 3.5 are input pins for timer 0 and 1. 3.6 and 3.7 are for read and write operations. And XTAL2 and XTAL1 are the input pins for crystal oscillators frequency. Pin 20 is for ground. Then pin 2.0 to 2.7 are port 2 IO pins. They are also the higher 8 bits for address bus. Then PSEN, it is used while accessing signal from external ROM. It is connected to OE of external ROM. Then ALE, it is address latch enable, used to separate data and address on port 0 when used as bus. Then EA bar, used to enable or disable external memory interface. Then P0.1 to P0.7, they are port 0 IO pins. They also act as data bus. And last but not the least is VCC. This is the power supply for our microcontroller. Here are some features of our microcontroller. It has 4 KB on-chip program memory, 128 byte RAM, 128 user-defined software flags, 8-bit data bus, 16-bit address bus, 32 general-purpose registers, each of 8-bit, 2 16-bit timers, 5 interrupts in which 2 are external, 4 8-bit ports, 16-bit program counter, 8-bit CPU. It works on 12 MHz clock frequency. One instruction's execution require at least 12 clock cycles, which is equivalent to 1 mission cycle. Hence, minimum time required to execute one instruction is 12 by 12 MHz equal to 1 microsecond. So for 8051 microcontroller, for executing one instruction, we require at least 1 microsecond. So that's it from this video. In next video, we'll see Kyle and Proteus. And if you like the video, then hit the subscribe button, share this video with your friends, and see you later.